Good morning, professor and classmates. Welcome to my final project presentation for English for Transportation and Logistics. My name is Chen Shenkai, and today I'm very excited to share my research title, Speeding into the Future, a comparative study of high-speed rail systems. I will be focusing on a deep comparison between the Japanese Shinkansen and the Taiwan high-speed rail. Okay. Before diving into the core topic, I would like to present my AI tool statement. For this project, I utilized Gemini and Grammarly to assist in my academic research and language polishing. Specifically, AI helped me organize complex data regarding chain specifications, technical metrics, and it refined the English flow for better clarity. However, I want to emphasize that as the presenter, I personally verified all facts, carefully selected the case studies, and adjusted the tone to ensure absolute academic integrity and accuracy. Okay, now let's look at the system overview. What exactly is high-speed rail, or HSR? By definition, high-speed rail is a type of rail transport that operates significantly faster than traditional rail systems. The global standard requires these trains to achieve speeds above 250 kilometers per hour on dedicated. Specialized tracks. The primary purpose of HSR is to bridge long distances in extremely short times, allowing railways to effectively compete with domestic air travel. Functionally, it serves as a highly efficient mass transit system for vital regional corridors. Okay. High-speed rail systems share several core features that distinguish them from conventional freight or slower passenger rail networks. First is velocity. These trains consistently maintain operating speeds of 300 plus kilometers per hour, which is achieved through advanced aerodynamics and powerful propulsion. Second is safety. HSR features automatic train control, or ATC, alongside dedicated grade separated tracks to eliminate the risk of collisions. Finally, HSR stands out for its sustainability in an area of climate change. HSR is incredibly green, producing up to 90% less carbon dioxide per passenger compared to commercial air travel. Okay, next slide. Let us look at some incredible performance metrics. When we look at the data, 300 plus kilometers per hour is the standard operating speed that redefines modern geography. But what is even more impressive is the number zero. That represents the zero fatal accident records over decades of operation. Because of this flawless track record, HSR is globally recognized as the safest mode of land transportation in human history, particularly exemplified by the operations in Japan and Taiwan. Okay, let's move on to our international case study, the Shinkansen in Japan, managed by the JR Group, launched back in 1964. The iconic bullet train was the world's very first high-speed rail system. It has three key advantages. First, it offers unmatched punctuality. The average delay time per train is actually less than 1 single minute, which is mind-blowing given the volume of passengers. Second, it has superior earthquake detection through the advanced UREDAS safety systems, which automatically stop the trains during a seismic event. Lastly, it operates at a high frequency, running up to 16 trains per hour during peak commuting times. Okay, so the next slide. However, even the best systems face critical challenges and operational hurdles. For Japan, the primary issue is aging infrastructure. Maintaining 60-year-old tunnels, bridges, and tracks requires massive, escalating financial investment. Second is Japan's difficult geography. The routes have to across extreme mountains and terrain and deal with the heavy snowstorms in the northern regions. Finally, there is intense market competitions from domestic low-cost carriers, combined with a shrinking aging national population that threatens future passenger demand. Now let's look at the Hong at Taiwan High Speed Rail, or THSR. The THSR corridor runs right through western Taiwan, stretching over 350 kilometers and connecting the major economic hubs. Operating since 2007, it completely revolutionized Taiwan's domestic travel by transforming a tedious 4.5-hour highway journey into a fast 90-minute trip. There were three major success factors here. First, Taiwan successfully adapted Japanese Shinkansen technology to fit our unique local tropical climate. Second, strategic station placement has stimulated massive regional growth in suburban areas. Third, it has become an indispensable integral part of Taiwan's one-day living circle. Okay. To clearly visualize this massive impact, let's look at the travel time comparison between Taipei and Kaohsiung. Going by highway bus take approximately 270 minutes. Taking the traditional TRA rail takes about 210 minutes. In sharp contrast, the Taiwan high-speed rail takes a mere 90 minutes. This means THSR has slashed total travel time by an astonishing 66%. This drastic reduction has fundamentally boosted business efficiency, enhanced corporate flexibility, and connected families like never before. Okay, so the comparison table. Okay, let's bring us to a direct side-by-side comparison table between these two exceptional systems. So looking at technology, while Japan utilized a pure Shinkansen core, Taiwan opted for a unique hybrid system combining Shinkansen trains with European signaling standards. In terms of punctuality, Japan remains the undisputed world record holder, but Taiwan is also excellent, maintaining a rate above 99%. Regarding challenges, Japan battles an aging infrastructure and population decline, whereas Taiwan's primary challenge is managing overwhelming passenger capacity during peak holiday hours. Finally, for pricing, Japan's Shinkansen tickets are relatively high, while Taiwan's fares are kept highly affordable and strictly regulated by the government to serve the public interest. Reflecting on this comparative study, we can draw some profound lessons. What Taiwan learned is that technology export requires deep localization. The custom-built 700T train was specifically modified to fit Taiwan's unique geography, tunnels, and seismic risks. We can model this relationship through technical efficiency equation that balance maximum velocity against total power and maintenance costs. Furthermore, Taiwan's uniqueness lies in its business structure. Unlike Japan's state-owned origins, the Taiwan High-Speed Rail was executed as one of the world's largest build, operate, transfer, or BOT, projects showcasing a brilliant synergy between private enterprise and government support. Okay, in conclusion, let me summarize the key takeaways. Both the Japanese and Taiwanese system define global engineering excellence. The Shinkansen is the grand technological pioneer, while the THSR stands as the flawless global model for successful cross-border technology transfer. Through this project, my personal learning is that I realize how critical integrated logistics and international cooperation are in modern transport networks. Looking ahead, sustainable smart mass transit will undoubtedly continue to be the absolute backbone of global economic growth and green urbanization. Okay, on this slide, I have listed my academic references and which include official operational reports from the Taiwan High-Speed Rail Corporation, the safety achieves from Japan Railways Group, and analysis from Commonwealth magazine. I have also included my detailed AI use statement here to maintain full transparency regarding how generative AI supported my initial drafting, data extraction, and vocabulary enhancement. Okay. So to conclude my presentation, I would like to leave you with this inspiring quote: "Railways are the through arteries through which the blood of business flows. High-speed rail is truly the heartbeat of modern economic vitality." Thank you very much for your time and attention. I'm now open to um um thank you for your listening. Okay.